All right, so let's work on these, draw the shear moment diagram for these. I think I'm going to shortcut it a little bit because I know you guys are all capable. I'm going to go ahead and just tell you what the reactions are. You can probably figure it out pretty easily yourself. With a quick calculation, you'll find that the shear here at A is equal to P, and that the moment is going to be PL. So we know we're going to start. By the way, what is the moment at a free end? If you don't have an applied moment there, it's 0. Let's think for just a second, what's the shear here at this free end? It's a little tricky. So why don't we just for a second imagine that little piece of material at the free end. So I'm going to draw a free body diagram. I'm going to cut it just to the left and look at that little right-hand piece. Okay? So there's the little chunk of beam with the load P on it. On the left-hand side, this is positive shear, right? So if I sum forces in the y direction there, what's my shear equal to? The shear is positive and equal to P. So when I get to this free end, I should have a value of positive shear. Okay? You like that? I don't know if you like it or not, but that's what it is. So we'll start here with shear. So what's this shear value at the beginning on the left side? Our reaction tells us it's P. So I'll come over here and say it's P. Now we know the change in shear is the area under the load diagram. What's the area under the load diagram for the whole beam? 0. So that means I should end up at P. And that's what I should have ended up with. That was easy. What's the shape of the curve in between? Well, it says the slope is equal to the load, and the load is 0. So that means the slope is 0, which means we get a horizontal. So in this particular structure, the shear is constant at positive P everywhere. Okay? Now, let's do the moment. What is the moment at the left side? We found it from our reaction. What kind of bending moment is that? Positive or negative? Negative. So we're going to start off at negative PL. What's the moment at the free end? 0. Is that what we think? Well, let's see. We know that change in moment is equal to the area under the shear diagram. So looking up here, from 0 to L, what's the area under the shear diagram? PL, and it's positive. Right? This is positive area. So if you start at negative PL and you add PL, you get 0. It's great when things work out, isn't it? What about the slope of the moment diagram? What is it equal to? It's equal to the shear. What is the value of the shear all along the beam? It's constant, and it's positive P. So here's a positive slope. That's constant. In fact, if you looked at it, you would see that the slope was P to 1, and that's your moment diagram. So where's the maximum moment in this structure? At the fixed connection is equal to negative PL. In fact, the moment in the entire structure is negative. So how would you expect this beam to displace? It should bend down, right? Our frown, remember our frown and smiling analogy? Our beam is frowning. Okay? Any questions? I'm just going to do the same thing over and over and over and over. I'm probably going to say the same words over and over and over. Because you should approach the problems in the same way every time. Imply these same things over and over and over. It's the same path. Don't get off the path. Not yet. let's start with this guy. You're going to find out when you do the reactions here that there is no shear. If you sum forces in the y direction, there's no applied force, so there's no shear. But you are going to find that the moment when you sum forces does have a reaction, equal and opposite. So let's start. What is the shear at the left edge? It's 0. What's the shear over here, do you think? Probably 0. The change in shear is the area in the load curve. What's the area in the load curve? 0. So that matches. The slope of this line connecting these 2 points is equal to the load. What's the load? 0. So you have no shear. The shear diagram, I'll draw it, but not really much to draw. There it is. No shear. Now let's do the moment. What kind of bending moment do we have at the left edge? Is that positive or negative bending moment? Positive, and that's going to be m naught. What's the change in moment? What's the area of the shear diagram? What's the area of the shear diagram? 0, so there's no change in moment. So it says that the moment at the free end should also be positive m naught. Hey, look at that. It matches. The slope of the moment diagram is equal to the shear. What's the value of the shear everywhere? 0. That means the slope is constant, and it has a value of 0. So this is a very interesting structure in that it has a constant moment. These would not be good tests. They would be good test problems from your perspective. They would not be good test problems from my perspective. I think if you guys want to hang around long enough for when I retire, maybe my last semester, I'll just give the simplest test imaginable. Everybody will get an A. I'll do Dr. Mo.